Now you may be pleased to know that we are about to cover our last data structure before moving on to some more exciting programming concepts such as control flow that make our programs come to life. But first things first, let's understand sets so we can use them in our programs when use cases crop up. So what is a set? Well, a set is simply an unordered collection of items, where every set element, i.e. the item in a set, is unique. In other words, you'll never find a duplicate value in a set. Now, every element in a set must be immutable in nature. So as you know, this means it should contain things like strings and integers, for example, as these cannot be changed. However, a set itself, i.e. the data structure, is actually immutable, so we can perform more methods on them than we observed with tuples. For example, we can add or remove items to and from a set. Now, sets can also be used to perform mathematical set operations like union, intersection, and symmetric difference, all of which we will cover later in this section. Now, creating an empty set isn't the same as creating an empty list or an empty dictionary by simply placing a set of brackets, for example. So let's find out in the next video how we create sets as well as how we create an empty set. Let's take a look at how we can create a set. Now, a set can be created in two ways. Firstly, we can place elements inside curly braces, separated by a comma. Now you may be thinking, but isn't this the same set of curly braces used for dictionaries? And you would be right, yes they are. But the difference being that the items included in sets are values, and not the key value pairs like we see in dictionaries. Now, sets can have any number of items, and they may be of different types, so things like integers, floats, tuples, strings. But as mentioned in the last video, a set can only contain immutable objects, which means a set cannot have mutable elements like lists, dictionaries, or even other sets as their elements. So let's see some examples. Firstly, we'll create a variable called my_set. We can then put an assignment operator, and we will then open a set of curly braces. The first set that we'll create will be a set of integers. So we can put 1, 2, 3, and 4 as elements inside of these curly braces. When we run this code, we've created a set. And just to prove it, if we place my_set inside the built-in type function, we can see we've created a set. Now, inside a set, we can also have mixed data types. So if I were to create my_set_1 and set this to a set of curly braces, we can also include floats, so we can put 9.2. We can then have strings, so I can enter the string hello. And we can also include tuples, for example. So we'll put a tuple with the integers 1, 2, 3, and 4. Now notice here I have just used immutable types, so we have floats, strings, and tuples, which are all immutable types. Now, as I've also previously mentioned, sets cannot have duplicate values. So if we now create my_set_2, and we set this equal to a set of integers, so I'll put 1, 1, 2, 2, 3, 4, and then 5, and 5, you can see that when we run this code and then take a look at my_set_2, inside of this set we have the integers 1 to 5, but there are no duplicate integers within this set because they've been removed. Now, I did mention that sets cannot contain list elements because lists are mutable objects, but we can create a set from a list, and the way we can do this is by using the built-in set function. So if I now create another set, my_set_3, and we set this equal to the set function, inside of the parentheses I can now put a list object. So let's just put a list of integers, and we'll put 1, 1, 2, 2, 3, and 3. Now when I run this code, we get a valid set. And if I take a look inside my_set_3, you can see that we get a set of integers 1, 2, and 3, and once again the duplicates have been removed. Now if we did try to include a mutable object inside of a set, let's say a list, we will run into an error. So if we create my_set_4 and set this to a set of curly braces, and inside we were to put the integers 1, 2, and then the third element we will include a list with the integers 3 and 4, you can see that we run into a type error, telling us that we have an unhashable type of list. So just note, you will run into an error if you do try to include a mutable object. Now if I were to ask you to create an empty set, you may be thinking, well, if the type of brackets used are curly braces, we can just put curly braces. But this would be a trick question, because if you remember, this would create an empty dictionary. Now empty curly braces will make an empty dictionary in Python, and just to prove it, if we set the variable my_dict equals a set of curly braces, and then I check the type of my_dict, you can see that we return a type dict. So to make an empty set without any elements, we use the set function, which we've just seen, and we don't provide any arguments inside of the parentheses. So if I type my_set_5 and I set this equal to the set function without passing any arguments into the parentheses, if we now pass my_set_5 into the built-in type function, you can see that we get a set object returned. So a slightly different way of creating an empty data structure, as we need to use the built-in set function as opposed to only utilizing brackets of interest when creating lists or dictionaries. So to summarize, you can create a set by placing items inside curly braces. These items need to be immutable in nature, which means we can't include mutable elements like lists, dictionaries, or even sets. We can have different data types within sets, so we can have integers and mix the data types, so include floats, strings, and tuples if we so desire. Now if you try to create a set with duplicates, the duplicates will be removed, so you will only have unique values contained in the set. You can also use the built-in set function, which will enable you to create an empty set, as well as being able to create a set from a mutable object like a list. So practice creating different sets so you're comfortable with the concept.